Many popular explanations of quantum physics describe the vacuum as an empty void, where virtual particles magically pop into existence from nothing before vanishing. This framing is rhetorically efficient, but ontologically reckless. The TCGS-SEQUENTION framework corrects this. The vacuum is not nothing. It is a highly structured projection interface, a domain of latent relational configurations that haven't yet been stabilized as physical objects. Think of it like the surface of the ocean. We see the momentary, cresting waves, but we are often blind to the deep currents and pressures below that actually dictate where and how those waves appear. Treating the vacuum as ontological emptiness is a category error. It forces us to view the universe as a collection of isolated events rather than a single continuous structure. We have an inherent object bias. We assume the temporary cresting wave, the physical particle recorded by our detectors, is the primary building block of reality. Yet, these particles are notoriously unstable. They decay, transform, and disappear. This instability forces a difficult question. If the physical carriers are temporary, what in the universe is actually permanent? The STAR collaboration recently provided the data needed to answer this. By colliding protons at nearly the speed of light, they mapped stable, invisible relations that persist even when the particles themselves are destroyed. The results suggest that particles are not standalone entities. They are readable signs, temporary carriers for a permanent, invisible relationship. Inside the structured vacuum, virtual strange quarks exist in a specific latent state. Because of the vacuum's own internal rules, these quarks are locked into a fixed spin correlation pattern before they ever become physical. To see this pattern, the experiment uses high-energy proton collisions to excite the vacuum and liberate these virtual quarks from their latent state. Here, we hit the barrier of confinement. Confinement acts like a geometric shadow filter, an admissibility rule forbidding isolated quarks from entering our three-dimensional world. This triggers hadronization. The illegal quarks violently reorganize into permitted hadronic objects called hyperons. Hadronization is the universe aggressively enforcing the geometric rules of our three-dimensional projection. It ensures that only legal configurations can stabilize into measurable particles. This process allows us to run a strict scientific stress test, the invariant transfer criterion. We start by identifying the original latent relationship, the spin correlation between the quarks. Next, we confirm the transformation. The original quarks were completely destroyed and replaced by hyperons during hadronization. The carrier class has changed. The data reveals a massive discovery. The new hyperon objects displayed the exact same spin correlation as the destroyed quarks. The relationship survived the destruction of its carriers. These entirely new physical carriers have taken on the precise relational signature of the quarks. When the physical object is rewritten but the relationship remains intact, we are forced to conclude that the relationship is the more fundamental constant. This carrier crossing behavior points toward a hierarchy flip. If a relationship can endure while its physical carrier is destroyed and replaced, then the relation is more stable than the matter itself. In the TCGS-SEQUENTION model, objects are temporary shadows. They are three-dimensional projections cast by a deeper, permanent four-dimensional reality called Counterspace. This redefines decoherence. When hyperons separate and their spin correlation appears to vanish, we aren't seeing the destruction of the underlying pattern. The shadow has simply lost its projection readability. It disappeared from our three-dimensional map, but the four-dimensional source remains intact and unchanged. A fading signal in an experiment is a failure of the map, not the destruction of the territory. This shifts the goal of physics. Instead of hunting for new hidden particles, we should be chasing invariant survival, finding the relationships that persist across different experiments. The playbook for the future is to smash the carriers, force them to change, and track exactly what data survives the transition. We have to move past the idea that the world is a collection of hard, fundamental little spheres. We are living inside a projection interface. Our physical reality is the shadow trace of a timeless, four-dimensional structure.